Hello and welcome to another edition of the TES Secondary Maths Resource of the Week with me, Mr. Barton. Now, you are in for an absolute treat here. If I said to you the topic of gradients and distances between two coordinates, can you think of any exciting ways to spice it up, make it a bit more engaging? I'll be honest with you, I know I can't. But then I came across this resource and my life has never been quite the same since. My life certainly teaching gradients and distances anyway. It's a flipping wonderful game, this. So it consists of a PowerPoint, and the easiest thing for me to do is just show you this PowerPoint. So, firstly, the author, let me just give a bit of credit to the author here, L.A. Lorimer has some of the neatest writing I've ever seen. I'm very jealous of that straight away. So here it is, it's just a single side of A4, gradients and distance game. So the game works on a grid like this. So this particular one is a 3x3 grid with two spaces for each of the units on the axes there. And it's a two-player game. And the game starts with the first coordinate is placed in the origin, and then player one goes and places a coordinate wherever they like. So in this case, the first move might be to place the coordinate there at B. So that would be 1, 2 at the point 1, 2. And then player one must work out the gradient that joins up points A to B, so in this case positive 2, and the distance between A and B, and in this case root 5. Done. Round one complete. Then it's player two's go, and player two places the point C, so in this case they've chosen to place it at 2, 1. And then they've got to work out the distance between points B and C, in this case root 2, and the gradient of the line segment that joins B to C, in this case -1. And this game continues with the twist being that you are not allowed to place a point somewhere that gives you a distance that you've already covered or a gradient that you've already covered. Wonderful, right? Because what's this doing? Well, this is getting kids to practice, obviously, working out the distance between 2 points and obviously working out the gradient between 2 points. But I think it's more than that because it's getting them to practice it in an engaging way. So straight away, by the time they finish this particular game, they've done what? 8 distances and gradients, performing 4 of them and checking 4 of them. So that's a bonus for a start. I also like the way it reinforces the best way to do the distance and gradient, because the fact that it's on a grid here naturally lends itself to drawing your right angle triangle to work out the distance and the gradient, seeing the connections, the way that right angle triangle can do both distance and gradient and so on. I love the fact that the competition element means that kids have an incentive to check each other's work, because that's often the problem with these games. Kids just go ahead, game. I'm getting through loads, blah, 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 blah. How do you know they're getting it right? And I'm nicking this as if it's my own phrase, but when I watched Danny Quinn, head of maths at Michaela, give a talk not so long ago, she said practice doesn't make perfect, practice makes permanent. And I flipping love that, because if kids could play in this game but getting it wrong, they're practicing the wrong thing, but they've got an incentive to get it right because the other person's going to be checking it for them. So absolutely wonderful for that aspect as well. But there's another brilliant bit that you can do for this, and it's very much like the factors and multiples game that I'm a huge fan of. Once you've played the game competitively, you can flip it on its head and say to the kids, all right, now work together. What's the longest game you can do? What's the longest chain of points you can make without repeating a distance or without repeating a gradient? I'd love to say I have the answer to that myself, but I don't. But it's a wonderful investigation. And they're getting all that purposeful practice whilst they're investigating it as well. Absolutely fantastic stuff. Really good stuff. Couple of kind of words of warning with anything like this. We've mentioned the fact of kids getting the answers wrong potentially. I'd be tempted to give a counter out. I love giving a counter out. I give a counter out to each player. And they can use that if they need to kind of call me over to check something. So say player one does a move, player two checks it and isn't happy, and they can't reach an agreement, then they can get the judge over and I'll come over and adjudicate and so on. So I think that's a decent idea. Secondly, and again, without stating the obvious, this game should only be used once kids are relatively comfortable working out distance and gradient. You don't want to suddenly stop the game halfway through to do a bit of reteaching. And it might be an example just to perhaps leave the sheet, print the sheet out and put it next to the students, just so they've got a couple of examples of how the game works and a couple of correct distances and gradients and so on. But look, I just think this is an absolutely wonderful game. It's niche, it's teaching a bit of a niche topic, gradients and distances, But flipping heck, it's fantastic. I'm a huge fan of that. And already my brain's starting whirring, thinking, can I apply this to something else? Is it versatile in that way? Wonderful resource. If you've enjoyed it, hop back onto the resource page, leave your thanks with the author, and I shall return with a fresh resource of the week next week. Take care of yourselves. Bye for now.